In this video, we delve into the alarming phenomenon of thawing permafrost, often referred to as a ticking time bomb for greenhouse gas emissions. As global temperatures rise, vast areas of once frozen ground are starting to melt, releasing trapped gases that could exacerbate climate change. We'll explore the nature of permafrost, the risks it poses to our ecosystems and infrastructure, and the urgent need for effective mitigation strategies to combat this looming threat. Join us as we uncover the complex effects of this climate crisis and discuss how we can work to avert disaster. 1. Understanding permafrost. Permafrost is an intriguing natural phenomenon that captures the imagination. Picture a vast expanse of soil that has remained frozen solid for at least 2 consecutive years. This is permafrost, found predominantly in the coldest regions of the planet, like the Arctic. It acts like a giant freezer, preserving organic matter such as plants and animals that have died and been buried over millennia. This frozen ground is not only a geographical wonder but also a critical component of Earth's climate system. Permafrost covers almost a quarter of the northern hemisphere, making it a significant player in global environmental dynamics. 2. The thawing threat. However, the stability of permafrost is under threat due to rising global temperatures. As the planet warms, this once permanent ice begins to thaw, much like an ice cube melting on a hot day. This process is not just a simple change from solid to liquid, it has profound implications for the environment. The thawing permafrost releases previously trapped gases, such as methane and carbon dioxide, into the atmosphere. These gases have long been locked away, but with the current climate trends, they are now being freed, contributing to an increase in greenhouse gas emissions. 3. Methane release. A potent threat among the gases released from thawing permafrost, methane stands out as particularly menacing. Methane is a potent greenhouse gas that has a far greater ability to trap heat in the atmosphere than carbon dioxide. This means its impact on global warming is disproportionately large, even if it is released in smaller amounts. When permafrost thaws, the organic material within it begins to decompose anaerobically, releasing methane. This gas then rises into the atmosphere, exacerbating the greenhouse effect. The release of methane from thawing permafrost is akin to opening a Pandora's box of climate challenges. 4. Carbon dioxide emissions. A silent contributor. While methane grabs the headlines, carbon dioxide is also a significant concern. As the organic material in permafrost decomposes, it releases carbon dioxide, another greenhouse gas that contributes to climate change. Unlike methane, carbon dioxide is more prevalent but less potent. Nevertheless, the sheer volume of carbon dioxide that could potentially be released from thawing permafrost is staggering. This contributes to a steady increase in atmospheric carbon levels, further driving global warming. The release of carbon dioxide from permafrost is a silent contributor to an escalating climate crisis. 5. Impact on ecosystems. The thawing of permafrost has a ripple effect on ecosystems. As the ground destabilizes, it disrupts the habitats of various animals, including polar bears, reindeer, and Arctic foxes. These creatures depend on the frozen landscape for survival, and as their environment changes, they face new challenges. For instance, polar bears rely on sea ice for hunting seals, and as permafrost thaws, this ice melts, reducing their hunting grounds. Similarly, reindeer and Arctic foxes may find their food sources dwindling or habitats becoming inhospitable. The impact on ecosystems is a poignant reminder of the interconnectedness of Earth's systems. 6. Infrastructure damage in cold regions. Thawing permafrost poses a significant threat to infrastructure in cold regions. Roads, buildings, and pipelines that were once stable are now at risk of destabilization as the ground beneath them shifts. This can lead to costly repairs and pose safety risks to communities. Imagine a road built on solid ground suddenly becoming a series of cracks and holes as the permafrost thaws beneath it. Buildings may tilt or collapse, and pipelines can rupture, leading to environmental disasters. The economic impact of such infrastructure damage is enormous, underscoring the far-reaching consequences of permafrost thaw. 7. The positive feedback loop. One of the most concerning aspects of thawing permafrost is the positive feedback loop it creates. As greenhouse gases are released from permafrost, they contribute to global warming, which in turn leads to more permafrost thawing. This cycle is self-reinforcing, making it a particularly challenging issue to address. It's like a snowball rolling down a hill, gathering momentum and size as it goes. The more permafrost thaws, the more greenhouse gases are released, accelerating the pace of climate change. This feedback loop is a stark reminder of the urgency needed in addressing climate issues. 8. Mitigation strategies. Despite the challenges, there are strategies that can help mitigate the effects of thawing permafrost. Reducing overall greenhouse gas emissions is a crucial step in slowing the thawing process. By transitioning to renewable energy sources and improving energy efficiency, we can reduce the amount of heat-trapping gases in the atmosphere. Additionally, monitoring permafrost regions is essential for understanding and predicting changes. This involves deploying technologies to track temperature changes and gas emissions. By taking proactive measures, we can hope to curb the rapid thaw of permafrost and its associated impacts.